So yesterday's homework assignment, at the end, you had those few problems where it was either in row echelon form and you had to solve by back substitution, or it was in reduced row echelon form, and that one's really easy because then you know exactly what x, y, and z or whatever variables you have are. Okay. In the problems that you'll do tonight, you will have a matrix or a system, and this is actually the system from yesterday. So if you flip back, you had to write a system as an augmented matrix, and that's this 2x minus 5y plus 5z equals 17, negative x plus 3y equals negative 4, and x minus 2y plus 3z equals 9. Okay, so you might be given a system on tonight's homework. You first write it as an augmented matrix, okay? And then your goal is you choose the row operations that give you row echelon form so that you can solve by back substitution. So the hardest part about this is if we forget what our goal is, then you can start to kind of get lost in your row operations. So remember, your goal is a row echelon form. You can look back at those bullet points from yesterday. If you have a row of all zeros, that's at the bottom of the matrix. But in a system, you probably won't have a row of all zeros. The first non-zero term in a row is 1. So you can have 1 at the front, or you can have 0, 1, 0, 0, 1. Okay. And that as you go higher up in the matrix, your 1 is more to the left. So really what you're trying to do is create a diagonal of 1. So starting up at the top left of your matrix, have a diagonal of 1s going down, and underneath every 1 is only zeros. Okay. You can have other terms behind the 1, so you can have other values above a 1, but underneath a 1 it has to be all zeros. Okay, so when I'm doing this by hand, one thing that you'll have to notice, we can all do it differently. Luke's choice could be different than Logan's choice, can be different than Fiona's choice, and we're still all going to come up with the same answer in the end. So there isn't one set of row operations that you have to do. What I usually do is I look over my matrix at the beginning and I just check, are any of the rows already good for row echelon form? So do any of the rows have leading 1s or zeros in the front? I think row 3 looks good, right? Row 3 would be great for row echelon form if it were at the top of my matrix. So let's do a switch of rows, interchange 2 rows. Remember that you want to also practice writing this part where you tell me what you're doing. On quizzes and tests, I can't give you partial credit if I don't know how you got the next row, and matrices are really hard to tell what rows you changed. So basically, if you don't write these things down, I have to take off all the points because I don't know what you did. Okay, so you got to write this down. Switch row 1 and row 3. So row 1 is now going to be 1, negative 2, 3, and 9. Row 3 is going to be 2, negative 5, 5, and 17, and row 2 will stay the same. Okay, so I like to do that at the very beginning. Are any of the rows good to go? Move them wherever they belong. Okay, so I'd say row 1 is set. I don't have to change row 1 anymore. I'm focused on row 2 and row 3. And I always think it's generally a good idea to kind of work yourself down your matrix. So I'm going to focus on row 2. What do we need in row 2 to get row echelon form? You could do it that way. What are you trying to get, Logan? You're trying to get a 0 underneath this one, right? Underneath this one has to be all zeros now in this first column. So we want the first term to be a 0, and Logan's saying just add row 1 and row 2. Won't that make 0? Yeah. Okay, so we'll make a new matrix. Row 1 will stay the same. And we're not going to change row 3 either, so I always kind of like write the rows that stay the same. And my row operation that I'm going to perform, I'm going to do row 1 plus row 2. And I'm going to place that wherever row 2 is. If you write row 2 plus row 1, that's fine. Okay, but it's on the second row, so we know we're doing it to the second row. So add 1 and negative 1, we'll get 0. Add negative 2 and 3, and we get 1. That's awesome. That doesn't always happen, but we created a 0 and we got a leading 1. So it's like killing 2 birds with 1 stone, right? Got 2 things down. 3 plus 0 is 3, and 9 plus negative 4 is 5. So now I'm looking over my matrix, thinking about my goal, row echelon form. Row 1 is good, and because I got my 0 and my 1, row 2 is good, right? So now I put all my focus down on row 3. What are we going to need in row 3 for it to be row echelon form? 0, 0, 1, right? We need that diagonal of 1s to be complete. So I just kind of like work from the outside of that row in. How could you get a 0 for your first term? Using the first row, we could multiply the first row by negative 2 and add it with the third row. We have to perform row operations. So we're using our rows. We can multiply by non-zero numbers. We can add multiples of rows to other rows. And we can interchange rows. So we're using those 3 basic row operations. So I would keep row 1 and row 2 the same. And then I'm going to take my row 3 and I'm going to subtract 2 times row 1 from it. Or you can say negative 2 row 1 plus row 3. Doesn't matter. The other benefit to writing these row operations as opposed to like just for me, it's really good for you because you have to do this for all 4 entries in that row, right? So if you get lost, you just go back here and say, wait, what am I doing? I'm taking the entry in row 3 and subtracting 2 times the entry in row 1. So 2 minus 2 times 1 is 0. Negative 5 minus 2 times negative 2, that would be plus 4. Negative 5 plus 4 is negative 1. 5 minus 2 times 3 would be 5 minus 6, negative 1. And 17 minus 2 times 9, that would be 17 minus 18, negative 1. Okay, we're getting closer. You can probably pick your next row operation, right? Remember what we said we needed? We needed a 0, 0, 1. So add row 2 to row 3. We have a 1 and a negative 1. If we add those together, that's going to give us our 0. So that would be 0, 0, 2, 4. You know, if you're trying to change row 3 to introduce a 0, I'm not really going to use row 1 again if I've got that 0 in the first spot, because by using row 1, I would reintroduce a number. So then I know I kind of have to do something with row 2. Okay? And that's why it's nice if you work down your matrix, you'll kind of get there. We're super close, right? We have a diagonal of entries, but we need it to be a diagonal of 1s. So the last step is divide by 2. What are you really doing to that row? Multiplying by 1/2. So we're going to do 1/2 times row 3. It will be 1, negative 2, 3, 9, 0, 1, 3, 5, and 0, 0, 1, 2. So I got to the goal. I have a diagonal of 1s. Underneath every 1 is a 0. I can have other numbers behind and above the 1s. That's fine. So on your quiz tomorrow, reminder, you'll have to do this. I'll give you a system or an augmented matrix, and you have to pick the row operations. But you can start it lots of different ways. Everybody can do it differently, but we'll all eventually end up with the same answer. I will say, like, every now and then you might choose some row operations where at some point, like to get my 1 in the second row, maybe I needed to multiply by a 1/3, but not everything divides by 3, so then that would be introducing fractions. So you kind of have to think about it very thoughtfully, like, would this be a good time to multiply by 1/3? Or should I wait until the very end? Because do I really want to introduce a whole bunch of fractions? Okay, you have that option. Okay, last thing, this is really a system. X minus 2y plus 3z equals 9. Y plus 3z equals 5. And z equals 2. So at the end of it, you go back and you solve the system like you did on your homework, except they gave you row echelon form. You didn't have to do all the row operations. Okay. Let's see. Well, z is 2. If I back substitute z into the second row, I'll have y plus 6 equals 5. So y is -1. And if I back substitute 2 and -1 into the first equation or first row, I'll have x plus 2 plus 6 equals 9. So x plus 8 equals 9. X must be a positive one. Okay. And this solution works for the 3 equations that you have here in row echelon form, 1, -1, 2. But note that if I go back up to the very top, where I had this like augmented matrix from this system, 1, -1, 2 works in all these equations as well. So if I did like the second equation, -1 plus 3 times -1, that'd be -1 minus 3, which is -4. So it's a solution to the original system. The row operations that you perform, goes back to yesterday where we said equivalent matrices, that you perform these row operations. It's really the same matrix, it just looks different. So you're solving the same system. Any questions on that? Will you turn the page? There is a 2-variable system, so this one will be a little bit quicker because you don't have as many rows to worry about. Will you write the augmented matrix, get it in row echelon form, and solve the system for me? And I will come around and peer at what you are doing. There's not one right way to start, so there's multiple ways to start this one. Try what you think you want to do. Okay, I see 2 schools of thought out there. Probably the most common one I saw walking around were people who said they were going to do row 2 minus row 1. Or you could switch that around, row 1 minus row 2. So they left row 1 alone, and then they subtracted row 2 minus row 1. So they got a 0, a negative 3, and a negative 9. That's 3 minus 6 and 7 minus 16. And that gets that 0 in the front, and now their main goal is to get their leading ones. Okay, so you might then say, I will take half of row 1, and this would be like one time I think it's okay to do multiple row operations is if you're just multiplying rows by scalars. You're not like adding and subtracting. And then on this one you would do negative negative 1/3 times row 2. So that when the first one, everything goes down by a half, so I'll get 1, 3, and then 8, and then multiply by negative 1, 3 in the second row, I'll get 1 and positive 3. And you might have done those as two different steps, that's fine. I usually don't do 2 row operations at once, but multiplying by a scalar seems pretty reasonable. Okay. The other method that I saw out there was some people said, let me multiply row 1 by a half right away, like, because aren't I trying to get a 1 in the first row? Yeah. So this one, I don't mind that because every term in row 1 is even. So then I'm not introducing any fractions. I'll get 1, 3, and 8. And then I have 2, 3, and 7. And I would guess most people then at that point to get their 0, they did negative 2 row 1 plus row 2. So they keep their row 1 the same, and they'll get 0. This will be negative 6 plus 3, which is negative 3. Negative 16 plus 9, which is negative 9. And again, multiply by a scalar to get my 1. If you did it the other way, you might have like a positive 3 and a positive 9. Okay. If you had, on this first one, if you had subtracted in the other direction. So this one, then I would multiply negative 1/3 row 2. And actually on this one, we come up with the same matrix. So the same system to solve. So we have x plus 3y equals 8 and y equals 3. So x plus 9 equals 8, therefore x is negative 1. So our ordered pair would be negative 1, 3. Questions, concerns about row operations, solving systems? Remember that on the homework there were those 2 questions, 41 and 42, where it asked you in part A to do the row operations and they told you what to do. And then they asked you in part B to like do solving like you would have normally in chapter 7. And then in part C it said like compare, which way do you like? So like think about it again today. Some of us are really going to like this matrix thing. We just organize our numbers, we get them all in rows and columns, and we just like try to get these ones and zeros, and it's just like, I like it. It's all numerical. And then some of us are like, no, it doesn't mean anything. I prefer to eliminate X, see my lines changing, stuff like that. So some of us may be like, matrices are awesome. And other people be like, I will just continue to solve my systems like the old way, algebraically. Okay? Just know that at the end of this chapter with matrices, we're going to do, we solve by row operation, so reduced row echelon form and row echelon form. We're going to solve by inverses with matrices, and we're going to solve by something called Cramer's rule, which uses determinants. So at the end of chapter 3, I'm going to give you 3 ways to solve a system with matrices, in addition to solving systems by graphing, elimination, substitution. So you have 6 ways that you could solve a system in your life. Obviously, like this one, if you're thinking back to our linear programming problems, remember, linear programming, all of ours were in 2 variables, because, like, what could we really do with more than that? Like, that's too much for us. But a real-world linear programming problem is going to have a lot of unknowns. Like, where am I going to put my next Starbucks? There's a lot of questions out there that I need answered. And so I would really probably set up a big program, and I would have a computer do it for me. So then matrices will be the way to go. Okay, so something to think about. Okay. Calculator time. Can everybody get out their calculators? Okay, if you have a Casio, You can come over here if you want to take a picture of this, if you want to copy it down. This little arrow for my Casios. Google is your friend. YouTube is your friend. They will teach you much faster and more clearly than Ms. Crosby, who does not know how to use Casio very well. These are like two different things that a student has told me before in previous class. I'm like, write that down on a sticky, and I put it in my notes, and this is what they tell me to do for matrices. I don't know what that means on your calculator. You give it a go and see if you can get it to work. If you're with a TI, the notes on the notes page, they work. Okay, so the thing to note about the TI, and yeah, come up and grab a calculator if you need one. We're going to solve this system. Do you see below the box there's a system down there? Okay, so if you're solving a linear system in a calculator, of course you need to change it to its augmented matrix. So 3, -2, 1, 15, -1, 1, 2, -10. And 1, -1, -4, 14. So we need to enter this matrix into our calculator. What is the order of that matrix? That is 3 by 4. Okay, an augmented matrix for a system usually is not a square matrix. Okay, so we're going to follow these steps. Follow along with me because I'm going to go to my calculator. We're going to select the matrix menu, which is second x squared. So I'm just going to clear all of this. Or not x squared, it's x to -1, which is right above your x squared button. So second x to -1. Do you see this nice matrix menu? Okay, it says select, edit, and choose a matrix. So this names is just like when you want to call it to your screen to do calculations. So you got to scroll over to edit. So use your arrow to go to edit. If yours is a brand new calculator no one's ever used before, you probably don't have any dimensions. If yours is like from a sibling or something like that, you might have matrices in there. It doesn't matter. I usually just like always re-edit A and B or whatever like the top 3 are. I don't think I've ever used matrix D before in my life because I don't need that many matrices. Okay, so I just always like overwrite these. Go ahead and click enter for A. And then it will ask you what order you want your matrix to be. So we want ours to be a 3 by 4. So you go ahead and type 3 by 4. And then you need to enter the system as an augmented matrix. Now notice when I wrote it in my notes, I have those colons. When you're putting it into the calculator, you don't need to really worry about them. Okay? So you won't have the colons, which signify the equals. You just type it in like I do. And it's always a good idea to just like look one more time. Did you get the correct signs? You will want to do 3 by 4. Okay, so once you've got all the entries into the matrix, this is where on the Texas Instruments, the matrices are kind of cumbersome. Now I'm like here in this matrix and I need to get out of it. So I think it's number 4A says second mode to get back to your home screen. So you need to like get out of this edit matrix. So you're going to do second mode. Mode is right next to the second button. It just quit. Anytime you want to get out of a screen, do second mode. Okay. Now we go back to the matrix menu and we call on we're going to put it in reduced row echelon form, and we're going to call on the matrix too. So go to second matrix. We've already edited our matrix. We're going to go over to math. This is where you can choose all the matrix operations. We are going to use determinant later, but we want either row echelon form or reduced row echelon form. You can scroll down, but I actually think it's closer if I scroll up. I have to hit it like maybe 5 times. If you have an option to let your calculator do the work for you, are you going to choose row echelon form or reduced row echelon form? reduce, because that's like the last two problems on the homework where it literally told us what X, Y, Z were. Okay. So we're going to choose reduced row echelon form, hit enter. And then you're going to do second matrix. And now you want to, in the names menu, choose the matrix that you want to do the reduced row echelon form for. So I want to do it for matrix A. And there it is. Now, if you're getting something different than I am, I would go in and check to make sure you wrote the right numbers for your coefficients, signs, and everything. Okay. But this is saying x equals 5, y equals -1, z equals -2. So I have my solution there. Okay. I'll come back over here. Okay, my RREF in the calculator, just so I kind of know what it looked like, was 1005, 010, -1, 001, -2. But that means my solution is the order 555, -1, -2. So that was super easy. I always say, think about that if you were taking the ACT and you know how to solve a system and you remembered how to do reduced row echelon form in your calculator. How fast you would have your solution. Be nice. Okay, does anybody have any questions about what we just did? Okay, your homework is here, page 548. Let's just think thoughtfully here. Should you be doing RREF in your calculator for all of these problems? No, right? You want to be able to do the row operations on your own. I'm actually fairly certain that if you follow the directions, it might tell you when it wants you to do a calculator, so I'm going to look at that real fast. Yeah, so when you get to 51 and 53, it says use a graphing utility. So then, like, use your graphing calculator. But if it doesn't say use a graphing utility in the directions, I would say do that one by hand. Your quiz tomorrow, I'll have to look, but I would say, like, it should be a no calculator. Like, you don't want to be doing RREF. I'm going to see your real operations. And then I know on the test, there'll be a part that's no calculator and a part that's calculator.